Hello and welcome back as we discuss our Week 9 topic, Legacy Software, Architecture Recovery, and Changes in Legacy Systems. We are going to discuss building and tracing legacy systems today. So we're still not quite at the place where we would be adding new features to legacy systems. This is more of a getting to know the system kind of conversation. So the very first step whenever you get a new project is, of course, we need to build the project, right? It makes sense that we need to start here. We can't safely change what we can't run. So building the project confirms that we have the right environment set up and the right dependencies for the project. We also know that a working baseline is going to be our safety net for future changes. So when we do reach that place where we want to make changes, we know that we have a working baseline to begin with. Now, when we're trying to confirm that the project runs and compiles, this can be kind of like a multi-stage process, right? We have to install any required like software development kits, any frameworks, any libraries, any kind of dependencies that might be missed, or add any environment variables that we might need. These things can be incredibly difficult to do if we don't have documentation. So if there aren't any, we should be documenting the build steps for ourselves and for other people. And if there are existing documents, there is nothing wrong with using them and then updating them if things have changed since that setup versus what you're getting done right now. The next thing we want to make sure that we do is we want to set up debugging. So we want to make sure that we're using some kind of IDE where we have tools that we can configure. So we can have breakpoints, we can watch variables, we're able to get a really good feel for the system. This will make sure that we can step through the code line by line, and we can also confirm that our logs or our console output are going to be visible. So then this way, as we're walking through the code and tracing through execution paths, we can add print statements if we need to and really make sure we understand what's going on inside this project. It's really important that we understand how the system behaves in real time and not just what the code looks like. So this is a pretty common pitfall for junior developers and undergraduate students, which is that we're given template code or our instructor shows us code in a video even, and rather than coding it up ourselves, we take a look at it, or even solution code, right? We take a look at it and we say, oh yeah, I understand what's going on here, and we consider that to be sufficient to sort of verify our understanding of a product or a code snippet. But in reality, that's not the same thing as understanding how a system behaves in real time. So when you get a legacy project and you're in the workplace, it would not be a good idea to just sort of read the code base and say, oh yeah, I get what it's doing, right? We need to actually make sure that we understand it in real time. This means booting up the project and setting breakpoints. We want to pause the execution at the start, making sure we know where the entrance into the code is, right? On method entries, we want to inspect variable values in the call stack. We want to make predictions as to where it's going to go next and then run it and make sure we're hitting where we expect. If you're not familiar with the debugging tool for the IDE that you're using, you should build a small project off on the side where you can get used to those tools before trying to use them in a major project, right? There's lots of steps to sort of build our confidence with the tool that we're using and then integrate that understanding into a legacy or active working system. We can use temporary log statements if we need to. One of my favorites, I love print statements. I think they're incredibly helpful. They help me understand the flow of execution. And what I will do is I'll actually go into methods and I'll just add print statements that say at where I am in the code. I'll put the method name. It's effectively like a cleaner call stack for myself. I'll put the method name and I'll put what portion of the code I'm in, and then maybe the values of the variables I'm watching. So they aren't just, random keys or the words hello world or I am in here. They're descriptive temporary log statements while I'm trying to understand a new system. This will allow us to capture variable values, timestamps, or even branching options if we put it inside if and else's, right? This also allows us to keep the logs very lightweight. So we're only going to put them where we need them. We can put them in places where it's easy for us to pull them out later. We're not looking to bog down the system. And then, of course, we just need to start by following the main scenario. So pick something that's common, that you know is a common user flow for whatever product we're working with, and start there. It's not going to be intuitive to sort of pick some random method and put a breakpoint and hope that you hit it, right? Let's start with a common user flow. If we know everyone starts at the login, put your first breakpoint at the login, and then trace your execution path through controllers, your services, your data layers, go all the way through and take field notes. It doesn't count as monitoring or observing if you don't write anything down. Then it's just passive watching. It doesn't count. Make some notes of dependencies, of side effects, of things that change so that you can refer to them later. So here we go. When it comes to actually making those notes, those field notes of your observation when you're running through some execution paths, we can take on the scratch path method. This is when we're going to track inputs and outputs of key methods. So when we come in, what goes into this method, and when we leave it, what comes out of it. Let's record where the changes to important objects or variables happens. So if something happens in a sub-method that we called into, we should be writing that down and making note of it. We should be able to easily identify where data is going to originate and where it's going to flow through. As we do this, and we'll talk more about this in the next video, but we should be starting to build a rough diagram of that flow of execution, right? We can make boxes for components, arrows to show the data flow or the method flow. This way we just start to have some idea of what's going on within a project. I'm going to talk about building those architecture diagrams when they don't exist in the next video, but this can also just be like a temporal flow of execution. Like we can just show, starting at main with this information, where did it take us through the application? It doesn't need to be anything fancy. So like I said, there are lots of tools that can help you trace, depending on the IDE that you're using. So for example, if you're working in Java and you're working in VS Code, we've got things like find usages or find references. So if you click on a method header, you're able to actually determine where that is being used. Where does that class get used? Where does that variable get called? We can make sure that, variables that are properly private are only being used where they should be, or determine how often variables are being set outside of a constructor. It's really good for spotting entry points of different pieces of information and ripple effects. So like where that data may go next, or where that method may kickstart a routine of multiple methods. We also have access to call graphs. These can be really confusing sometimes, but they're very helpful as well. So it allows us to visualize which methods call which other methods, and we can identify critical paths or where we hit a dead end. Where is the end of that call stack? So a call graph visualizes a call stack for us. Drawing something like this out for a whole project, depending on the size of the project, but for your purposes, would be too big. We probably wouldn't want to do that. We'd want to draw out a call graph for a specific method flow or a specific function, and like maybe have multiple call graphs, not one big giant one. We also have the control click or the go-to definition. So if we're walking ourselves through something and we're not really sure where the heck this call is, or where it's living, or it's really messy, or multiple methods with the same name, we can always jump instantly to a method, a class, or the variable's definition. And we can do this by following the code flow, and then we don't lose our place in our code either. So rather than stopping what we're doing, finding a different tab, scrolling through it manually, if we use the go-to definition, we don't need to lose where we actually were in our flow of execution after we've checked out that spot. So I want you to go and open a random method in your project, ideally one that you did not make yourself. So start at either the service layer or even better in your repository, and see if you can actually use the built-in tools to trace that flow all the way back to a UI element that is going to use the data it got from that method, right? Once you've done that, because hopefully your own project, now go to a different group's project that you have access to in GitLab and see if you can do the same thing. This is going to be really good practice for using these tools and also just getting a good sense for how this flow of execution sort of works its way through a project, even one that maybe you're not that familiar with. You can finish off this video's project pause and reflect by trying to sketch out a call graph for one of these methods that you've sort of followed through, whether it's in your project or in another group's project. And hopefully this will be a really nice foundation for you as you move into my next video, where we further discuss sort of sketching out an architecture diagram, especially when a project is sort of all over the place and not that organized. I'll see you in that video, and thanks for watching. Bye.